Hi, today we are going to talk about special relativity, and this video is aimed to give some mathematical insights into special relativity because most of the short videos I saw were mostly animation or something like that, and the videos which had mathematical insights were too big. So, this is something in between, like 10 to 15 minutes video, which will give some mathematical insights. Uh, so, so, why did it all start? So special relativity came into being because Maxwell proposed his theory of electromagnetism, which said that light is an electromagnetic wave and speed of light c is constant in all frames in the medium. So that means that if you are in a train which is traveling with say velocity v and someone shines light outside which is traveling at c, you won't see light at c minus v as you would expect, but light will still travel at velocity c with respect to you. So this was completely in face of Newton's classical physics, which says that it should be c minus v if you know basic Newton's classical physics. So something had to give way, and Einstein came and resolved the conflict. So basically, uh, in Newton's classical physics, there's an important concept called Galilean coordinate transformation rules. You must have seen these rules if in your 11th or 12th grade in physics. And even if you don't follow the maths, you can just follow the essence of this at a higher level, of this video at a higher level. But I will go through maths as well for audience which are more mathematically inclined. And just for even for audience which is more mathematically inclined, if they follow through the logic, I will upload snapshots of the maths that I have done, and you can go through it later if it's too fast for you. So these are the Galilean coordinate transformation rules. So basically, if speed of light is constant, we need new coordinate transformation rules. These won't hold true. This basically gives rise to c minus v, which is not right according to Maxwell's theory. So we need new coordinate transformation rules, which are called Lorentz coordinate transformation rules. Um, and we will use basic high school algebra to derive these Lorentz coordinate transformation rules, which replaces Galilean coordinate transformation rules. So Lorentz coordinate transformation derivation in 10 steps. So as you can see, this was the coordinate transformation rules. Now we replace it with more general coordinate transformation rules. X prime is b0 plus b1 x plus b2 t. T prime is a0 plus a1 t plus a2 x. Here t prime was equal to t. So in Newton's universe, time was same everywhere throughout the universe. This let's look at what is this prime and unprime. So basically, unprime is s prime frame, and this is s and s prime frame. X prime is in s prime and x is in s frame. S prime is moving towards right with velocity v with respect to s. So if you are in s prime frame, you will feel like s is going towards left, and if you are in s, you will feel like s prime is going towards right. Something similar that you see in train. So these are the coordinate transformation rules, and eventually we need to figure out these constants a0, a, b0, b1, b2, a0, a1, a2, and we'll figure out eventually. I will tell you initially that we will eventually figure out that a0 is 0, b0 is 0, b1 is a1, b2 is minus b1 v is minus a1 v, a2 is minus a1 by c square v, where v is the relative velocity between two people or two frames. And this everything we have figured out in terms of a1, and eventually we'll figure out a1 is 1 upon root 1 minus v square by c square. And since we figured out all this, if we substitute this in this, then we'll get x prime as a1 x minus vt and this. Okay, so let's look at the next slide. So you saw that we started with this. Now assume without any loss of generality, if you assume origins coincide, that is x t and x prime t prime is 0, then you get a0 b0 equal to 0. So this, since a0 b0 is 0, x prime will be equal to this, t prime will be equal to this. So we already figured out this a0 b0 equal to 0. Then s prime is moving towards right with velocity with respect to s. So when x prime equal to 0 in x frame, it will be vt. The coordinate will be vt. So if you substitute that in this basically x is vt, x prime is 0. We'll figure out, we'll take this there, we'll cut out t minus b1v is equal to b2. So b2 is minus b1v. So we figure out 4 and 1 2 and 4. Now we need to figure out 3 and 5. So now if we divide a by b, basically x prime upon t prime, we want to get to something similar to speed. We divide this, but the next slide has more details on it. So we divided x prime by t prime, we got this. We have b1 and a1 a2 here. Now s is moving towards left with velocity minus v with respect to s prime. So when x equal to 0, x prime is minus vt. So when you substitute x prime as minus vt, x as 0, this will go away, this will go away, and when you calculate, you will see a1 equal to b1. So you figure out 3. Now you have divided x prime by t prime. Now here you figure out a1 is equal to b1, so you will substitute this here. So you will just have b1 and a2. You need to figure out a2. But here we have a big divergence which we'll use to figure out a2. The big divergence is in Newton. According to Newton, c is not constant in all frames, speed of light, but according to Maxwell, it's constant in all frames. So if x prime by t prime, that is if there is some light propagating, then x prime by t prime will be c, and x by t will also be equal to c, since velocity of light is same in all frames in the medium. So here the trick is we divide by t, numerator and denominator. So here there will be x by t, here the t will be cancelled, t will be cancelled, here you will be x by, here you will have x by t. So if you substitute this as c, calculate, you will get a1 equal to minus b1c v by c square. Here there is only a2 and b1. So but b1 is equal to a1, so a1 v by c square. So we figure out this. So we figure out all constant in terms of a1. Now we need to figure out a1. What is a1? So for that, what we do is, when you substitute this in this, you will get eventually x prime t prime is a1 x minus vt, a1 t minus vx by c square. So we'll go to the next slide. So you figure out x prime t prime in terms of a1. Now you can figure out x and t in terms of x prime t prime, and when you go from one frame to another, you just need to flip the v sign, because as you saw earlier, with respect to one frame you move towards right, with respect to another frame you move towards left. So x and t will be a1 t plus t will be a1 t prime plus vx prime by c square. X will be a1 x prime plus vt prime. This will be plus, sorry. So once you substitute that here, these terms will cancel out, this middle terms will cancel out, and all when you calculate. So what you do basically is, x prime is a1 x minus vt, so you substitute x as this here and t as this here. So we will have x, this basically this is x, this is t. So when you figure out everything, these two terms will cancel out and more things will cancel out, and you will get 1 is equal to a1 square and 1 minus v square by c square. So a1 square will be 1 upon 1 minus v square by c square. a1 will be 1 upon the root 1 minus v square by c square, which is popularly called as gamma. So we figured out a1. So we had t prime as a1 t minus vx by c square. So we figure out t will be equal to gamma t minus vx by c square, and then we had t equal to a1 t prime plus vx prime by c square. So t will be equal to gamma t prime plus vx prime by c square. So if this is the coordinate transformation rule. So we figure out the coordinate transformation rule for time, which is gamma t prime plus vx prime by c square. Now if you take an infinitesimal, then it's delta t equal to gamma delta t prime plus v delta x prime by c square, since v and x are constant. In the rest frame, that is when particle is at rest, in that frame, s prime frame, delta x prime will be 0, because the particle is moving with the frame itself, so the coordinates won't change. So delta x prime will be equal to 0. So you will have this will be equal to 0. Delta t prime is called delta tau proper time, and just to differentiate delta t I will call capital delta T. So delta t equal to gamma delta tau. This is basically time dilation. And what are the implications? Now imagine, let's look at gamma. It's 1 upon root 1 minus v square by c square. If v is 80 to 90% speed of light, then this will come out to be approximately 2. If you substitute v is equal to 0.8 c or something like that, gamma will be equal to 2. So when 1 second passes for that particle, 2 seconds pass for an outside observer. So since this is at 80 to 90% speed of light, time slows down. If 1 year passes for this guy, for an outside observer, 2 years pass. Using similar stuff, you can figure out about length contraction and how mass increases with speed and all that. So as you could see, using just basic high school algebra, you could figure out the Lorentz transformation rules. So I will take you through the logic one more time. You start with very general coordinate transformation, figure out all the coordinates, all the constants a0, b0, a1, b2, a2, and finally figure out a in terms of a1, and finally figure out a1, which is gamma. And so you get the coordinate transformation rules, and from that you can easily see how time dilation works, etc. And you can even reach towards E is equal to gamma mc square if you follow through. Thank you.